Welcome students to this session. In this session, I'll be talking to you about lipoproteins. What does the name mean? It is a mixture of lipids and proteins. You have heard of these lipoproteins, LDL, HDL. I'll talk in detail about all of this. What is the main structure of all these lipoproteins? Please remember lipids plus proteins. And what are these proteins called as? The proteins are called as apoproteins, and they are all named as ApoA, ApoB, ApoC, ApoD. Like that they are called as apolipoproteins or apoproteins. Now, which are the lipids that are present in all these lipoproteins? They include cholesterol, phospholipids, triacylglycerol and cholesterol esters. The proportion of each of these, cholesterol, PL or TAG or CE, will differ depending on the type of lipoprotein. Now, all these lipoproteins have one common structure. They are all spherical in nature. They are all spherical. So, what will be present on the outside? So, on the outside, it is made up of phospholipid. This is made up of a phospholipid layer. This is outside. And what is present other than phospholipid? Cholesterol. Why cholesterol? Cholesterol is also amphipathic. So the polar heads will be towards the outside and the non-polar tails will be towards the inside. What else will be there present inside here? What else will be there? We always represented them as triacylglycerol. Please, we represent them as triacylglycerol. We can do it like this or like this, the 3E. So, glycerol with its 3 fatty acids. So, in the core, the completely non-polar lipids, the glycerol with its 3 fatty acid, triacylglycerol. What else is present in the core? Now, cholesterol by itself is amphipathic, but when it is esterified, when cholesterol gets esterified, that is cholesterol ester, what we call, when it is esterified with a fatty acid, it loses its amphipathic property. So, in the core, we have also cholesterol esters. So, the outside is made up of phospholipids and cholesterol, inside cholesterol esters and triacylglycerol. This basic structure remains true for whichever lipoprotein you are taking. What about the proteins? Right now I have talked only of the lipids. The proteins are there associated out here. Now these proteins, maybe some of them are tightly bound and some of them are slightly loosely bound. These proteins have got their own functions. Each protein has got a specific function, and these proteins are necessary to keep this whole thing intact. We need these apoproteins. For them to be, these lipoproteins to be recognized by different cells, we need these apoproteins. For enzymes to act on these lipoproteins, we need the apoproteins. So let's go further. Now these are all having hydrophilic shells. As I said, phospholipids, cholesterol and apoproteins. Hydrophobic core is usually neutral with triacylglycerol and cholesterol esters. And these are the transport vehicles for the lipids in the aqueous environment of plasma. So how are these lipoproteins classified? We know from beginning, so many times you have heard of this. There are 5 major classes. Now there are 2 ways. One is by ultracentrifugation and depending upon the lipid content, and the other is by electrophoresis. Both of these can be combined. You can use both them together. So 5 kilomicrons, they remain in the electrophoresis. They remain at the origin. They do not move. VLDL, they go to the pre-beta region. VLDL, what does the name indicate? Very low density lipoprotein. So on ultracentrifugation, they are differentiated based on their densities, and density depends upon what? It depends upon the lipid to protein ratio. More is the lipid or more is the protein, depending on that the density will change. So you have very low density, you have low density, you have high density. So depending upon the lipid content. So you have low density lipoproteins, also called as LDL, and this goes to the beta band. HDL, high density lipoprotein, or which forms the alpha band. Is this all? No, there is one more category, and those are the free fatty acids, the most metabolically active category of lipoproteins. Remember, free fatty acids also require a transporter, and the transporter is albumin. So we call this as free fatty acid albumin complex. To where does it move? Naturally, wherever albumin is moving, to that direction, this will be the fastest moving in a electrophoretic slide. So origin, pre-beta, beta and alpha lipoproteins, and the free fatty acid albumin complex. Let us go to the different classes of apoproteins. Now there are 4 major types: ApoA, ApoB, ApoC and ApoE. Now they are further subclassified as ApoA1, ApoA2, Apo3, B48, B100, etc., C1, C2, etc. Let us just look that there are different subgroups are there. Out of all this, ApoB48 and ApoB100 are important. Why? They are the products of the same gene. Just because there is a slight change in one of the nucleotides, what will happen? There will be a change into a stop codon. So at B48 is smaller when compared to B100. B100 it will go on till the end. At B48 it will stop. The 48 molecular weight it will fall, and B48 is smaller. Now what are the functions of this? They give structural integrity, lipoprotein uptake by tissues, recognize cell membrane receptors, and they activate enzymes. These are the functions of apoproteins. Now let us go on to the metabolism of each of these lipoproteins, because that is going to help you in understanding the atherosclerosis and other diseases. So let's start with chylomicrons. Now where are the chylomicrons synthesized? What is the function of chylomicrons and to where do they go? Now the site of synthesis of chylomicrons is the intestine. I am showing the intestine like this. So the intestinal mucosal cells secrete the chylomicron. This chylomicrons, please remember, this chylomicron, again it is always spherical in nature. The one which is synthesized from the intestine, we call it the nascent chylomicron. What does it contain? It has got a huge content of triacylglycerol. So it has got from where did this triacylglycerol come? It came from the diet. So the diet contains triacylglycerol. This triacylglycerol is digested, it is absorbed, and now it is into the chylomicron. Remember that one thing to be remembered is this dietary triacylglycerol, we call it as the exogenous triacylglycerol. So the site of synthesis is intestine. Now the main apoprotein that is present in chylomicrons is ApoB48. I keep on repeating, it is ApoB48. They are the products of the same gene, but in the intestine there is a mutation and it stops at that level. So the main apoprotein that is there is 48. Now this is still a nascent chylomicron. This nascent chylomicron further goes, it gets certain apoproteins. From where? From HDL. Which are the apoproteins it gets? It gets C2 and E. From where did it come? From HDL. HDL gives its ApoC2 and ApoE to nascent chylomicron. This chylomicron, which is now containing 3 apoproteins, which are they? 48, it is having C and it is having E. So all 3 of them, C, E and B48, with its huge triacylglycerol content, is now called as the mature chylomicron. This mature chylomicron, what is it still transporting? It is still transporting triacylglycerol. Now where is it present? Remember that this triacylglycerol go into the lymph and not into the portal blood. So the lymphatics will go, where do the lymphatics from the intestine drain? They will finally reach the systemic circulation and not the portal circulation. Remember, here they have bypassed the liver. They have gone via the thoracic duct, and at the level of the sternal angle, they have reached into the systemic circulation. Now in the systemic circulation, what is happening? Where do they go? They go to all the extrahepatic tissues. And now out of the extrahepatic tissues, what is important is there are 2 tissues which are important, and those are the adipose tissue, adipose, and the skeletal muscle. I am just going to show it like this: adipose tissue and also the skeletal muscle. Now what is happening in the skeletal muscle or the adipose tissue? Skeletal muscle or the adipose tissue, they have capillaries lining them. Now in the capillaries which are going through the adipose tissue or the skeletal muscle, there is an enzyme which is present in the endothelium of these capillaries. What is this enzyme? This is known as lipoprotein lipase, LPL. Now this lipoprotein lipase is stimulated by the C2 apoprotein. This C2 apoprotein activates lipoprotein lipase. So what will happen is, it is a lipase. It causes degradation of triacylglycerol into what? Into lipase will degrade this and release all that fatty acid into the adipose tissue and the skeletal muscle, and also forms glycerol. Remember what happens to this glycerol? This is formed. This goes to the liver. So now this chylomicron which has given out this TAG has been broken and it has given out its fatty acids and glycerol to various tissue. Now this, what is formed is a smaller compound, smaller lipoprotein. Now it is called as a remnant. What is this difference between chylomicron and chylomicron remnant? Is that it is depleted of triacylglycerol and it will be containing mainly ApoB48 or ApoE. Those ApoB48 and ApoE will still be there over here. This remnant is now then taken up by the liver. It has from the systemic circulation, it reaches the liver, and by the B48 specific receptors or by ApoE receptors, this chylomicron remnant is taken up by the liver. Remember, this glycerol also goes to the liver. The glycerol also goes to the liver for further action. So what has happened here? Dietary triacylglycerol has been transported to extrahepatic tissues and whatever is remaining has reached the liver. This is the main function of chylomicron, transport of exogenous triacylglycerol. I have shown it here. The major lipid is triacylglycerol. Function: transport exogenous triacylglycerol from the intestine to various tissue. I gave you the metabolism. Please remember that in the metabolism that ApoC2 activates lipoprotein lipase, and this is present in the walls of the capillaries, especially in the adipose tissue and skeletal muscle. The chylomicron remnant is smaller, contains more of cholesterol and cholesterol ester. These are also come from the diet and they are taken up with the help of B48 receptor. That is the metabolism of chylomicrons. Now we go ahead with the metabolism of VLDL. Now the metabolism of VLDL is somewhat similar to that of chylomicron, but the only difference is VLDL are synthesized from the liver, and the main difference is in the apoprotein. Now this apoprotein is ApoB100. This is ApoB100. This is also rich in triacylglycerol. But from where did this triacylglycerol come? This has come from endogenous. When did this happen? Remember, whenever there was excess calories, there was synthesis of fatty acids and there was lipogenesis that was taking place in the liver. This endogenous, that is synthesized in the liver, is transported out of the liver with the formation of VLDL, very low density lipoprotein. Now this VLDL also takes up ApoC2 and E from HDL. It also takes up, please remember, ApoB100 is still there for it. This is the only lipoprotein which other than LDL which contains ApoB100. So ApoB100 is still there. It is having lot of triacylglycerol. It also goes to the extrahepatic tissues. So endogenous triacylglycerol from the liver has been reached the adipose tissue and the skeletal muscle. Again, ApoC2 will stimulate lipoprotein lipase, hydrolyze triacylglycerol into fatty acids and glycerol. Glycerol goes back to the liver. Now comes the change in the metabolism. The change that is happening is, once this has formed, this lipoprotein without its triacylglycerol will form an intermediate density lipoprotein. IDL. Okay, this IDL, what is happening is it is having very less triacylglycerol, but is having lot of cholesterol and cholesterol esters. Now IDL is still having ApoC2 and ApoE. It gives out ApoC2 and ApoE to HDL. Once it gives out to it, it is now converted into LDL. LDL is what? Low density lipoprotein. This LDL is filled with cholesterol and cholesterol esters, and it is having only and only one apoprotein, and that is B100. So only one apoprotein B100 is present. What happens to LDL? What happens to IDL? Now IDL also can be retaken up by the liver. It can enter into the liver. LDL, before going to the liver or before going anywhere, what it does is it is taking the to extrahepatic tissues. It goes and gives this cholesterol to all the tissues. It is still there in the circulation. It gives this cholesterol to the different extrahepatic tissues. So this is a point to be remembered, that LDL is formed in the circulation from IDL or from VLDL. So from where is LDL formed? It has come from the liver. So LDL is responsible for the transport of cholesterol from the liver to the extrahepatic tissues. VLDL is responsible for the transport of triacylglycerol from the liver to the extrahepatic tissues. Which is the apoprotein that is present? Only B100. So let us talk about this. Now metabolism of liver VLDL is synthesized in the liver. ApoB100 is present. It is also with the nascent VLDL is formed, and then mature VLDL is formed. The major lipid is triacylglycerol. Transport endogenous or dietary triacylglycerol from the liver to the various tissues. It is not dietary compared to the dietary that is formed in chylomicrons. This is endogenous triacylglycerol, non-dietary triacylglycerol from the liver to various tissues. Metabolism I have shown to you. Metabolism of LDL. Remember, liver is the site where LDL is formed. It is VLDL, comes from VLDL in the circulation. The main apoprotein is ApoB100. And the major lipid is cholesterol. So it transports cholesterol from the liver to various tissue. Metabolism. Again, what is happening to LDL? Let's see in the various extrahepatic tissues. What happens here? How LDL transports to various extrahepatic tissues. Let us just be simplified. How LDL gives the cholesterol to various extrahepatic tissues. I'll just show you one thing, that in the extrahepatic tissues, there are certain LDL receptors. These receptors are present in what are called as, these receptors are specific for B100, and these receptors are present in what are called as clathrin coated pits. This is clathrin, okay? So whichever tissue which is having LDL B400 receptor and plus it is present in the form of a clathrin coated pit, the LDL will come and bind to it. Once it binds to it, this whole thing will invaginate and it will form a vesicle with the LDL in it. The clathrin will be reutilized. Please remember that the clathrin will get reutilized. First initially clathrin coated vesicle, and the clathrin coated vesicle will lose its clathrin and it will form a phagosome. Now it is called as a phagosome. This phagosome will come and bind with lysosome, just like the different other bacteria. So this LDL is still there here. The LDL is still there. This LDL which is present, which is filled with cholesterol, is in a phagosome. This combines with a lysosome, and now phagolysosome is formed, and then finally free cholesterol is released to the tissues. So free cholesterol is released to the tissues and this tissue can utilize it. What is important is LDL enters the tissue in the form of endocytosis using clathrin coated lipids with the help of binding to its receptor, that is B100 receptors. So LDL particles bind to specific receptors present in the clathrin coated pits on the membrane and they are taken up by endocytosis. So that is the importance of LDL and its metabolism. Now metabolism of HDL is much different from metabolism of LDL. Please remember that LDL is transporting cholesterol from the liver to the extrahepatic tissues. So that is where the problem comes. LDL is called as the bad cholesterol. Why? Remember, these extrahepatic tissues include the different endothelial cells and the macrophages that are present even in the endothelial cells, and that is why LDL can get deposited in atherosclerosis by ingestion. The same thing is happening in macrophages also. The macrophages can take up this LDL and finally release this cholesterol into the macrophages, and the macrophages are converted into foam cells. So that is the importance that you know that this thing can happen even in the macrophages which are present in the subendothelial areas, and they can lead to atherosclerosis. So LDL metabolism, let's talk about further about metabolism of HDL in the next class. Thank you.